Hello guys, welcome back to Math Zone African Motives. We are still on our N6, one of the most important topics, integration. And now it is on partial fractions. This is August 2023 exam that we are going to focus on. Use partial fractions to integrate the following. So we are given these two integrals, but it's a lot. Okay, no problem. Let's see. 3.1, we are given to integrate 1 minus x, everything over x cubed. All right, so I'm just going to write it like this. So this is over x cubed plus 2x squared plus x with respect to x. So these are partial fractions, guys. Okay, we are supposed to express as partial fractions. So the first thing that I said is that you are supposed to check always for this. Can I be able to factorize the denominator, right? Can this be factorized? So instead of us having this, let us just focus on the partial fraction on its own, right? So thinking of this, this is 1 minus x. Everything over, so we're going to have everything over x cubed plus 2x squared plus x. So in this case, the exponent that we have, the numerator here, the exponent is 1. Here it's a 3, so you can see that this is a proper fraction. So we can be able to simplify without any long division considered. But in the denominator, this can be factorized. We've got x, which is common. There's x here. So we can factor out that x. So meaning to say, this is going to give us 1 minus x, everything over the denominator. If we factor out x, which is our highest common factor, we're going to divide x cubed divided by x, which is going to be x squared. 2x squared divided by x, that will give us 2x. X and x, this is going to give us a 1 like this. All right. This is what we are obtaining. And this also can be written. Can we factorize this further? X squared plus 2x plus 1. We have to try. All right. X squared plus 2x plus 1. This, we have to try and see if it can be factorized. The coefficient of x squared is 1, so you're going to have x and x here. Do we have factors of 1? But these factors of 1, if we add them, they must give us a 2. Do we have such? Yes, 1 and 1. 1 times 1, that's a 1. 1 plus 1, that's a 2. So meaning to say we've got 1 and 1. So these two brackets are the same, just like 2 times 2 is 2 squared. So if these brackets are the same, just going to write this as x plus 1 squared. So this is simply means x plus 1 squared. So meaning to say here, we can write this as 1 minus x over x into the bracket. So this bracket here, we factorize this and we got two brackets of x plus 1, which are the same. So it's going to be x plus 1 squared. So this is the simpler part now that we have. So this is the one that we are supposed to work with now into partial fractions. Here we're just writing into a simpler format that we can express into partial fractions. At that stage, that's when we are supposed to express into partial fractions. How? Okay, the first part, x is a linear expression. This one, it's a linear term. So meaning to say, this is going to give us a over x. It's a linear term, so it's just a over x. Then on x plus 1 squared, it's called a repeated linear when you are given an exponent like that. All right, it's called a repeated linear. It's a linear raised to an exponent of 2. So from your formula sheet, you check that you've got a condition of a repeated linear that we are given here, that if you are given f of x over ax plus b, which is a linear but raised to a certain exponent, it is going to be a over ax plus b over ax plus b squared, and so on up to the last exponent. So we are going to raise this to the last exponent, which is n. So there we are given this being to the exponent of what? It was to the exponent of 2. All right, so meaning to say we are going to start with the first term. It's going to be plus b over x plus 1. So it's going to be b over x plus 1 plus C over x plus 1 squared. We are increasing because x plus 1 as it is like this. Then we move on x plus 1 squared and so on and so on. So it's going to be x plus 1 squared. We are ending at 2. We do not have a 3, so you're not going to have d over x plus 1 cubed. If this was a 3, then we are going to extend up to another term of a 3. That is the idea. So meaning to say here we are done, guys. We're going to equate what we have on the numerators. This part of the numerator, which is under the LCD. So this denominator here is the one that is carried all along across there. So that's your LCD. So you equate the numerators, all right? 1 minus x is equal to here. We're going to have a into what? We divide this to the LCD, x and x, they cancel. We remain with x plus 1 squared, all right? So this is going to be into x plus 1 squared, all right? Plus, we take this b on the next term is b, x plus 1 into x plus 1 squared. We are going to remain with x plus 1. There are 2 of them, so we remain with 1. But there's an x also, so it's going to be bx into x plus 1, all right? Plus c in this case, x plus 1 squared and x plus 1 squared, they do cancel totally. You remain with what? You remain with x. So this is going to be cx. So that is how you're going to equate your numerators. So at this stage, we have formed what we refer to like an equation, all right, that we can take advantage of this equation. We can take advantage of this. How? One, we choose for linear terms that we can express them to be equal to 0. Linear terms, I'm talking about like bracket, the bracket of x plus 1. I have also a bracket of x plus 1 there. So we can work with these brackets of x plus 1 if we let that bracket of x plus 1 to be equal to 0. It means x will be equal to minus 1. If you solve x to that, 1 to the other side, it becomes what? A negative. At a condition where x plus 1 is 0, we have eliminated this. We have eliminated everything because anything that is multiplied by a 0, it gives us what? A 0. But at that condition, for this bracket to be equal to 0, it means x must be what? X must be equal to minus 1. We solve for x. So we are going to substitute x, which is minus 1, on the left-hand side. So that will be 1 minus minus 1, which is a 2. So that's 1 minus, we substitute x, which is what? Which is minus 1 like this. So that's minus minus a plus, which is going to give us a 2. So this is equal to, on the right-hand side, there's no need for you to substitute because already we are saying this bracket is equal. So is equal to 0. So we have eliminated everything. We no longer have this part. It's no longer there. We have eliminated everything. So we are just focusing on this cx. When x is equal to minus 1, we substitute minus 1. So it's going to be minus 1 times c, which is minus c. So divide by negative 1, c is going to be equal to minus 2. All right, so if we divide by a negative 1 here, it cancels this, it becomes a negative 2. So c is what? Is negative 2. All right, let's move on to another part. We were focusing with the bracket of x plus 1 as our linear term. We are focusing with the linear terms. We also have linear terms here. We also have x and x here. So we can let that x to be equal to 0. If this x is equal to 0, it means the whole of this part is now a 0 because anything multiplied by a 0 is what? It's a 0. The same as the part of what? Of a c. It's going to be a 0. So let us substitute on the other side. If x is equal to 0 here, we're going to have 1 minus 0, which is what? Which is 1. So 1 is equal to, we are going to focus on this part, not these other ones, because x is out of the bracket. Here, we do not have x out, it's inside. So it's 0 plus 1, which is 1 squared. That will be 1. And 1 times a is going to give us what? A. So you just substitute on your calculator, you're going to get a 1. You multiply to a, so a is equal to what? A is equal to 1. All right, so this is what we have for A. Then, in order for us to find, we are left with B. So we do not have any other bracket that we can say, let this bracket be equal to 0. All right, or any x. We are done. We used the bracket of x plus 1. We use the x. So what you do when you have exhausted everything, you have used everything, you expand the brackets and equate everything that you are given the coefficients of equal terms or the terms that are the same. So we have to expand our brackets in this case, okay? You have to expand the brackets on the right-hand side. So the left-hand side is already in expanded form, all right? So you're going to expand and equate the coefficients of equal terms. So the left-hand side, we've got 1 minus x, which is equal to, we expand what we have on the right-hand side. All right, so here there's x plus 1 squared. Remember from the identity, guys, that I always talk about of a plus b squared, where we say this gives us a squared plus 2ab plus b squared. Our first term here is x squared. So this is going to be, its x is going to be x squared plus 2ab, that's 2 times x times 1, which is 2x, plus b squared, that's 1 squared, which is 1. But take note, there is a outside of the bracket. So everything after expanding x plus 1 squared, you get this x squared plus 2x plus 1. But you are supposed to know that you have to affect everything by what? By a. So that's a times x squared, which is going to be ax squared, a times 2x. So this will be 2ax. All right, a times 1, which is going to be 2a. So this is what we are going to have, okay? You expand using that identity of a plus b squared. All right, we are done on this part of a. You move on to bx. So bx is going to expand everything, bx times x. So this will be plus bx squared. All right, x and x is going to give us x squared. Then bx times 1, which is going to give us bx. All right, the part of cx is already in simplistic form, so there's nothing going to do, just going to write as it is cx. All right, so this is bx squared, this is bx. All right, once you have expanded, take note, here we have a, b, and c. We have calculated a and c. So we are focusing on calculating what? On calculating b. All right, take note about, we are focusing on calculating b. So on focusing on calculating b, meaning to say we are supposed, yes, we are supposed to equate the coefficient of x squared, but we have to check, do we have b on the coefficients of x squared? There's x squared, there's x squared here, there's a b. So meaning to say I can work with that, it's fine. So let us work with the coefficients of what? X squared. So we are going to equate the coefficients. We are talking about the coefficients in this case of x squared. So on the left-hand side, we do not have x squared. Meaning to say the term of x squared, it was multiplied by a 0. It was 0x squared. That's why we do not have x squared. So the coefficient there, it's a 0. The number that is affecting x squared, if it is not there, it means it's a 0. So 0 is equal to, we move on to the right-hand side, the coefficient of x squared, this is x squared. The coefficient, the number there, the term affecting x squared is what? It's a. You move on to the coefficient of x squared again here, which is a b. So that's a plus b. You take the number as it is. So here you can find the value of b since we have the value of a. So 0 is equal to a plus b. We have the value of a that we determined before. So it's going to be 0 is equal to 1 plus b. So to find b transpose 1 to the other side, it becomes minus 1 is equal to b. So that means we've got our b as what? As -1. All right, so that's it here. We have got the value of b, a, and c. So we are going to substitute back into the format here that we are given. Remember, we are having our partial fraction here that we wrote in this format. A over x, a over x. So we are going to have a, which is 1. So it's 1 over x. So the whole of this part, it was a over x. So this whole part is going to be 1 over x. All right, we move on to the part of b. According to our expansion, it's b over x plus 1, b over x plus 1. Our b in this case is -1. So it is going to be -1 over, remember, it's x plus 1. All right, we move on to the other term, which is the last part here, which is the part of c. It was written as c over x plus 1 squared. C is -2. So that's -2 over x plus 1 squared. All right. -2 over x plus 1 squared. This is according to our format, the way. So maybe you wrote a different format. Maybe you started with x plus 1 squared. You are going to have this on this part, but still having its minus 2 as it is. It depends with how you wrote it. All right. So this whole part was an integral. We have got our partial fractions done here. We have completed the part that we needed, the application of our partial fractions. But the whole question was on what? On integrate. We are supposed to integration. We are supposed to integrate this. So it's on integration. So you're supposed to integrate with respect to x. All right. So this is what you're gonna do. You're gonna integrate this with respect to x. Is it possible for us to integrate? Yes, it's very, very possible. We can integrate just like the previous part, each and every term separated so that we properly see our integrals, all right? So this will be, this one, you can just take it as it is, the integral of 1 over x with respect to x, all right? Then this will be minus outside, so it's gonna be 1 over x plus 1 with respect to x. We take minus 2 out, so it's gonna be minus 2, 1 over x plus 1 squared. So this will be x plus 1 squared like this with respect to x. All right, so let's integrate. The integral of 1 over x, I always say this, guys, this is a ln. So this is going to give you a ln. Minus, also there we've got 1 over, as long as it's a linear, it's gonna be a ln. So you're gonna have a ln as long as the 1 over there. So this will be a ln. So it's going to be a ln x plus 1 over the first derivative of x, of which the first derivative of x is what? It's 1. So affecting by 1 does not affect anything. So it will remain as what? As ln x plus 1. All right. Minus 2 in this case, we're supposed to integrate 1 over x plus 1 squared. So how do we integrate this? All right. There we're supposed to think of, let us do this way. Okay. The integral of 1 over x plus 1 squared. This one you can just use substitution because it's going to be a u here. Gonna let, all right, no problem. Let me do this way. I'm wasting my time. Let me do this way. This is the same as the integral of x plus 1 to the exponent of minus 2. Remember, if we take this up. Remember from our integrals, we said if there is a bracket like this, you integrate the bracket, like you integrate the way it is, like the way you see this bracket as it is, so it's going to be x plus 1. You add 1 on the exponent. So if we add a 1, it's going to be a negative 1. All right, over the new exponent that you are given, which is negative 1, but you have to multiply by the derivative of this linear x, which is x in this case. So in that case, the derivative of x is just a 1, so it does not affect. All right, so this is going to give us negative 1 over x plus 1. All right, so we take this down, it becomes 1 over, but the negative here, you just write it what? On top. So this is what you're going to get. All right. So here we are going to get, let me explain another way. We are going to get negative 1 over x plus 1. So this is what you were supposed to obtain from your integral. This is now the integral. We are now talking about what? The integral at this stage. All right, plus the constant of integration. We could have integrated this way using substitution method because we can see that this is a linear. So you can work with the u to be x plus 1, and we know that this is going to cancel the derivative of u with respect to x. If we differentiate x, it gives us a 1. The derivative of 1 is a 0. So that means in this case, du is equal to dx. So if du is equal to dx, that means here we are going to have the integral of 1 over x plus 1, which is x plus 1 is u. So that will be u to the exponent of 2. And dx and du are the same, so this will be du. All right, so that means 1 over u squared is the same as u to the exponent of negative 2 with respect to u. So we are back again, add 1 on the exponent, that's u to the exponent of negative 1 over negative 1 plus the constant of integration, this and that. You have your substitution. So this was going to give you minus 1 over u plus the constant of integration. But remember, your u in this case is what? X plus 1. Your u is x plus 1. So it is going to give us minus 1 over x plus 1 plus, which is the same as this one, minus 1 over x plus 1. So if you know this method here, it's going to be easier than for you to use substitution, because substitution was going to work, yes, but it is easier for you to know that. Remember from our N5, we talked about this, that if you integrate a certain nature of this, the integral of ax, let's say ax plus b like this, to the exponent of n with respect to x. So you integrate the bracket, which is going to be ax plus b to the exponent of n plus 1. Remember, integration, we add, so it's going to be n plus 1 over n plus 1 times the derivative of of this ax, which is I in this case. So that was our formula that we had in our N5. So this is exactly what we have. If we write this, it was going to be the integral of, we take this one on top. So it will be like this, x plus 1 to the exponent of minus 2 like this. So if we check here, we are going to add 1 on our exponent. So that is where we got x plus 1 to the exponent of what? Minus 1 if we add 1. Over the new exponent, which is minus 1 times. Here, the derivative of x here is just, if there was a number like 2, you're going to multiply by that number here. But here there is what? A 1. So it does, we don't see the effect because there is what? A 1. So that is how you apply your formula. Okay, so we just hope to see or to have more questions as we move on, so that we'll be able to explain with the different examples, but that is how you integrate that. So at this stage, you can just combine your terms. So this is going to be the ln of x, all right, minus the ln of x plus 1. All right, minus, that is going to be what? A positive. Minus here is going to be a positive. So multiply, because this is something like over what? So numerator to the numerator, it is going to be 2 over 1 times x plus 1, which is x plus 1 plus the constant of integration. We are done. There's no way, there's nothing that you can do unless maybe you want to apply your laws of logarithms, you divide, but at that stage, it's fine. In our syllabus, guys, you obtain full marks. So that is how we were supposed to play around with this question. As long you have managed to have your partial fractions done, the rest is now your integration. You have to go back to the normal, your basics of your integrals, all right? So the first part is for you to make sure that you find your values of A, B, and C in an appropriate manner. We have to find those values exactly. Then after finding those values, you have to substitute your A, your B, and your C. Then integrate whatever that you goes. This is the same thing as what we have here. So we are supposed to integrate that with respect to x. So that is the whole idea of the question. All right, let's check 3.2. Again, we have a partial fraction there. So we are given this 3.2. So on 3.2, you're asked to integrate, that is minus x squared plus 1. So this is minus x squared plus 1 over 3 minus 2x to the exponent of 3 like this. All right, with respect to x. Okay, so if we check this one, it's a repeated linear that we have, which is the first part that I was showing you guys here. Okay, let me go back to those formulas again. This is it. The one that we have got an exponent of n, where I said we're going to use our repeated linear to formulate the first one over ax plus b over ax plus b squared, ax plus b to the exponent of 3, depending with the exponent. So that one, it is to the exponent of 3. So you're supposed to end up with the 3 terms of this nature because it's end up at what? At 3. So you expand according to the exponent that you are given up to the end. All right, up to the end. So that exponent was a 3. So meaning to say we are going to expand up to 3 in this case. All right, this is what you're going to do. So we are going to take this to let this part of negative x squared plus 1 over 3 minus 2x. So this is 3 minus 2x to the exponent of 3 be equal to, so like I said, you're going to raise from 1 up to 3, right? So it's going to be a over 3 minus 2x. So this is 3 minus 2x plus b, All right, so we're going to have plus b over, we move on, 3 minus 2x, this time to the exponent of what? To the exponent of 2, plus to the exponent of what this time? To the exponent until it reaches a 3. So it's going to be 3 minus 2x to the exponent of a 3. 1, in this case, 2, 3. That is the repeated linear. This is a linear, but being repeated a lot of times. So you expand up to the last exponent. Once you have this, you are back now so that you can be able to calculate for A, B, and C. So equating the numerators, we've got minus x squared plus 1, which is equal to A, which is our numerator. Yes, we're going to have A into this part, take note, is 3 minus 2x into the LCD, which is the whole of this fraction. So there are 3 of them, the 3 minus 2x. So if we divide by 1 of these 3 minus 2x, we are going to remain with 2 of them, 3 minus 2x squared. Okay, because there were 3 of them, and we've divided by only 1, so we're going to remain with 3 of them. The same thing here, plus a b, we do the same thing, 3 minus x squared. So if we divide these ones, they are 2, and here they are 3. So if we divide, how many are going to remain? We are going to remain with 1 of the 3 minus 2x. What about this part? There are 3 of them, and these ones are 3. So if we divide, what is going to remain? Nothing. It's just going to be a 1. So they cancel each other. So that's a 1. So it's going to be plus c times 1, which is just a c. So this is what you're supposed to have. So at this stage, we can work with the linear. Remember, the idea here is to make this to be equal to 0. This one is a linear, so it's possible for us to equate this to be equal to 0. So if we let this bracket of 3 minus 2, because it's a linear, so we can solve for x. So we are going to let the bracket of 3 minus 2x to be equal to what? To be equal to 0. So if we let this linear bracket to be equal to 0, it means we can be able to solve for x. That will be minus 2x is equal to, transpose 3 to the other side, it becomes what? A negative. So if we divide by negative 2 by negative 2, it means our x is going to be given as 3 over what? 3 over 2. So this is the value of x. That is going to make this to be a 0, because at that we took it when that was equal to 0. So it means at that x, which is 3 over 2, this bracket is going to be a 0. This bracket also is going to be a 0. So we've eliminated this bracket, also eliminated this bracket. So what is going to happen? We are going to substitute on the other side there. So that is the condition. So when x is equal to minus 3 over 2, let us substitute on the left-hand side and see what you're going to have. All right, so on our calculator here, you're going to have x is minus x squared. So it's minus, I'm going to put the negative out. So it's minus x squared. Our x is 3 over 2. So this is 3 over 2 like this. That is how you substitute it properly. Plus a 1. So this is going to give us negative 5 over 4. All right, so this is going to give us negative 5 over 4. All right, which is equal to, when this same x is 3 over 2, we substitute here. Is there anything to substitute on this side? There is nothing that we are going to substitute on this side, right? Take note here, there is nothing that we have, right? It's just a c, so it is just going to be equal to c, because here this one gave us a 0, this one gave us. If you want, you can substitute. This is it, guys. If you want, you can substitute 3 minus 2x is 2 times x. Remember, our x is what? 3 over 2. So 3 over 2 like this. But do not waste much time in exam doing this, because that is where the purpose of you finding that x is, because you wanted that to be a 0. So why do you have to substitute again if you wanted it to be a 0? It's now a 0, so it's no longer there. There's nothing here. All right? So that is the idea there. So now ask yourself again, is there any other part that you can substitute or the part of the bracket now that we can work with to make it to be equal to 0? We do not have it. We only had this linear part here. That was the only linear part. So it means the rest, if we are out of ideas, we have to expand. That is the only way out. So we are left with the only way out we are left with here is to expand the brackets and whatever so that we equate the coefficients. So the left-hand side remains as it is, minus x squared plus 1 is equal to, all right, if we were to expand this using our concept of a minus b squared, remember I said a minus b squared is equal to a minus b squared is equal to a squared minus 2ab plus b squared. So that means our a being the first term, which is 3, our b being 2x. So it's a squared, which is 3 squared. 3 squared is 9, all right? Minus 2ab means minus 2 times a, which is 3, the first term, which is 3, times b, our b, which is 2x. So it's like this. So you multiply this and this. Minus 6 times 2, which is minus 12. So you're going to get minus 12x there. All right, I hope we are together. Then b squared, the last term squared. So it's 2x, which is our last term squared. So 2x squared, 2 to the exponent of 2, that's a 4x squared. So this will be plus 4x squared. This is where we are now. All right, so that is what you're supposed to have at this stage. And not forgetting that there's an a which is outside. So whatever that you just have here should or must be multiplied by what? By the a which is outside. So let's multiply. A times 9, which is going to be 9a. A times minus 12, all right, is going to be minus 12ax. Okay, a times 4x squared, this is going to be plus 4ax squared. All right, we've multiplied everything by a, everything by a, everything by a. We're done. Okay, so let us move on to the part of a b, and this the rest of the part. Okay, so they're just going to expand b times 3, which is going to be 3b. B times negative 2x, it's going to be negative 2bx. C, there's nothing that we can do on C. It's already in simplest form. So that is what we have there. Remember, we have the value of C. What we just remain is A and what? A and B. So we are focused on calculating A and what? A and C. So let us see if we can be able to have the value of A or the value of C. Let us start with the coefficients of x squared. Equating the coefficients of x squared means that we're going to have on the left-hand side, the coefficient of where there's x squared there, the coefficient there is what? Negative 1. It's minus x squared. So it means the number affecting x there is what? Minus 1. That is the coefficient. So minus 1 must be equal to the coefficient of x squared on the right-hand side, provided that it's there. If it's not there, we do not force, we move on to another one. So we have x squared here, which is 4a, that is our the coefficient of x squared, which is plus 4a. So we are going to equate this to 4a, the coefficient of x squared. So divide by 4, it means our a is going to be minus 1 over 4. All right, that's our a. So we have a now. We focus on finding b, so we are going to move on to the other part. We can think of the coefficient of x. So equating the coefficient of x, we need a part where there is x. That is the coefficient of where there is x. What is affecting x? So on the left-hand side, we do not have x. So it means it was a 0x. So the coefficient there is a 0. The number, if it is not there, it means it was 0x. So that will be 0 is equal to the coefficient where there's x. We do not have x here. All right, here there's an x. Here there's x. So we're going to equate this minus 12a. We take the coefficient of x, which is what? Minus 12a. Combine to another part where there's x. We've got x here, the coefficient of x, which is what? Which is minus 2b. So it's minus 12a minus 2b like that. All right. So this can help us to find the value of b. We do not have any other part where there's x. So this can help us to find by. We have the value of a that we calculated before. So 0 is equal to minus 12 times, okay, let us just do this, minus 1 over 4 minus 2b. So you can take the 2b this side, it becomes what? A positive. So 2b is equal to, so I'm just going to simplify this. 12 times minus 1 over 4 is what? Minus 3, is that so? Minus 12, let us just put our calculator here. All right, that's negative 12. My mind is tired now. Minus 12 times negative 1 over 4, negative 1 over 4 like this. So this will give us a 3. All right, so this is a 3. All right, remember, we took this negative 2b to the other side. It's now a positive what? It's now a positive 2b. So to find b, we can divide by what? By 2 by 2. So b is going to be equal to 3 over 2. All right. So here we found our b. Here we found our a, and also our c, which is negative 5 over 4. So we are supposed now to bring these solutions back to our integrals now. All right, back to the part of what? To the part of our partial fraction that we had. All right, let me get this here, where we had the first part, it was a over 3 minus 2x. All right, so this is a over 3 minus 2x. So this simply means it is equal to a, which is minus 1 over 4 over 3 minus 2x. So this is 3 minus 2x. All right. The other one was what here? B over 3 minus 2x squared. So b, which is a positive. So it's plus b, which is a positive, 3 over 2 into 3 minus 2x squared. Remember there's an x squared. The last term was plus c, all right, to the exponent, and it will be to the exponent of 3. Our c is minus 5 over 4, all right? So the part of c is c over 3 minus 2x cubed, and c is minus 5 over 4. So this is going to be minus 5 over 4 like this. Remember, it was supposed to be plus minus like this. Okay, let me write it like that, the way that we all understand. All right, 3 minus 2x to the exponent of what? Of 3. So this is what our partial fractions can do. They help us to separate like what we did from a single fraction that we had. Now we have got separated terms, separated fractions. So from those separated fractions, now we are supposed to integrate. So meaning to say, the whole part of our question now is we are supposed to integrate what we see here with respect to x. But we are supposed to have a format that allows us to integrate this, each and every part. All right, let's start with the first one. We can take the minus 1 over 4 out. So this will be minus 1 over 4 like this, the integral of, so we are going to remain with 1 over 3 minus 2x, okay? We do the same thing, plus 3 over 2. We take the 3 over 2 out of the integral, so you're going to remain with 1 over 3 minus 2x like this to the exponent of a 2. Right, then you have got minus 5 over 4, so you're going to take the minus 5 over 4 like this, the integral of, so you've got with respect to x, so you're going to have 1 over 3 minus 2x to the exponent of what? Of 3 with respect to x. All right. So now we are supposed to integrate. Each part here is supposed to be integrated. So the first one, we've got minus 1 over 4. I want us to see properly on the first one. We can do our integrals direct on the first one. In fact, like all of these ones. So it's minus 1 over 4 like this. Remember what I said about this type of a function. I said on this type of a function that we are seeing here, it gives us a ln. So it's going to be ln of the f of x that you're given. So it's ln 3 minus 2x, all right? Ln 3 minus 2x like this. Over the first derivative, you differentiate the part of x minus 2x. If you differentiate that, it gives us what? A negative 2. So you are supposed to be careful now on that part, all right? It's different from that part when there's just a 1 or it's just a direct 1. Here there's a number, so you divide by negative 2 so that you multiply that side. All right, so plus 3 over 2, we are supposed also to find the integral of 1 over this. And we said if it is given as a fraction like this, it means we can have this as 3 minus 2x to the exponent of what? Of negative 2 on top. And I said, like, you integrate as it is, the way that you see it, the bracket as you see it with the exponent of what? Negative 2, where we add 1. So it's going to be 3 minus 2x to the exponent of negative 1 over the new exponent that we got, which is negative 1 times the derivative of what is inside for x, the part of ax, the derivative there is, which is what? Negative 2. So meaning to say this is going to be negative, negative, which is a positive. So it's going to be 1 over 2 into the bracket. All right, negative is the one that cancels, there's a 2 there. So into the bracket of what? 3 minus 2x to the exponent of 1. So we take to the exponent of negative as what? As 1 over. So this is what you're supposed to have in this case. So meaning to say here on this integral of this part, all right? Sorry, here we are here. On this integral of this 3 over 2, the integral of this, we are going to get this answer here, which we said is going to be 1 over 2 into 3 minus 2x, like that. All right, so this is what you're supposed to have. So it is the same situation like this part here that we are seeing here on this part of minus 5 over 4, minus 5 over 4 like this. So we're going to integrate this. So it is the same now. This is to the exponent of what? Of 3, of minus 3. So you integrate the outer bracket, you integrate it. So it's going to be 3 minus 2x. You add 1, so it's going to be a minus 2. All right? Then we divide by the new exponent, which is negative 2 times the derivative of this ax, which is going to give us negative 2. So negative, negative, positive. So that is going to be 1 over, already there's a number, 2 times 2, which is a 4. So it's 4 into 3 minus 2x to the exponent of what? Of 2. So that's how you get rid of that. All right. So this was going to be 1 over, all right, the integral of the whole of this part here to the exponent of 3 was going to be 1 over 4 into the bracket of 3 minus 2x. Minus 2x squared. All right, so that is it here. We have integrated everything. So you're going to have the constant of integration. That's it. So there are terms that can be integrated that are direct. We can work with those terms direct. We can integrate them direct, all right? Then after that, we can just combine. Remember, there's a negative here in the denominator, and there's a negative there. So you're going to negative, negative, which is positive. 1 over 4 times 1 over 2 is going to be 1 over 8. So this will be 1 over 8, the ln of 3 minus 2x. All right, we do the same thing. This is same as 1 over 2, so it's going to be 3 over 2 times 1 over 2, which will be plus 3 over 4. So it's 3 over 4, 2 times, which is 4. All right, in fact, here, because we do not have linear, let us multiply numerator, numerator, guys. Here, it's a fraction that can be combined together properly. 3 times 1, which is going to be 3 over 2 times 2, which is going to be 4 into the bracket of 3 minus 2x. It's best for us to write it that way, which is the same thing as also this part, minus 5 times 1, which is going to be minus 5 over, you multiply the numbers 4 times in the denominator, so it's 4 times 4, which is 16 into the bracket of 3 minus 2x to the exponent of what? To the exponent of 2, like this. All right, plus the constant of integration. We are done. Is there anything? Guys, here we are done. There's nothing that we're gonna do here. All right, so I don't know. It's up to you now, guys, that you choose to work with more persons, because we have like a hint of the topic where it is going now. From your N5, you can see where it is going. You can see exactly where you are going, and also the integrals that are supposed to be revised as you are working. Which integrals are you supposed to focus on? You can even tell, so, okay, now I'm supposed to focus on these integrals of this nature, these integrals of this. That is the focus now, because you can see that everything there, we have actually talked about it, and also with other videos that we had. So just make sure that you follow up those classes so that you'll be able to understand fully the whole of your course for mathematics N6. But these are the stages that you're going to have. So it's an interesting part. It's an interesting part. Partial fractions, it stretches your mind. Your mind is not limited. It stretches your mind further. That's the advantage of what partial fractions. It allows your mind to be stretched. All right. So like I said, we shall see for more questions to come. If there are any other questions that are necessary for us to revise together from this platform.